right, we've still got some folks filtering in, but I'm going to go ahead and kick us off a little bit. My name is Sarah Uranowski. I head up all things product marketing here at EnergyCAP, and I am excited to introduce Tom, who will start the webinar in just a minute. A couple of housekeeping notes. As Daniela has put in the chat, it is open and please use it. Hi, Jenny. Hi, Jean. We've got several folks coming in, but yes, please feel free to drop where you are chiming in from, what you're hoping to hear today, all those good things. Also, this is very much meant to be an interactive session with you. This content is for you, so type in your questions, raise your hand, ask whatever you'd like to ask as we go along. You don't have to hold on until the end for questions. The webinar will be recorded. It's being recorded now, so you will receive that recording along with the slides after the webinar is over. And of course, it will be on the website as well if you want to direct other folks to watch the recording. And I think that's it for me. So with that, Tom, I'm going to hand it off to you, and I will make sure to be watching our chat. Hey, Lucy. Hey, Nick. Hey, John. Nice to see you all. But I'll be watching the chat, and as we get questions, I'll make sure to let you know.
Thanks, Sarah. Appreciate it. And welcome in, everybody. For those of you that haven't had a chance to meet me yet, a little of my history, just so you know why I'm asking what I'm asking. Is I'm a former teacher, so spent a lot of time teaching students at varying levels. And I very much like to respond to questions. So if you have any questions as I go or need clarification, something, please raise your hand, slow me down. I really want to be responsive to those so that you get the maximum out of this. Another part of my history is I've spent 20 years in the energy industry using EnergyCAP and helping clients use it as a tool to calculate cost avoidance. And ultimately, the goal is to try to control costs. And that's what this webinar is about, is talking about cost avoidance. It's something that I think people are aware of and maybe a little hesitant to use or to understand. And hopefully over the next hour, we can get you a little more comfortable with what cost avoidance is all about. So with that in mind, kicking off, what I want to do in today's presentation or today's webinar is start with a discussion about projected energy prices, what prices are forecasted to be in the next handful of years. I want to make a case for cost avoidance. I've run into many people through the years who are uncomfortable with cost avoidance, and I want to try to dispel that, or at least uncover why I think it's so important that you understand what cost avoidance is. Backtrack a little bit and talk about measurement and verification basics. If you're not familiar with the term, I just want to unpack that for you. Just make sure you get familiar with M&V and also what's referred to as the IPMVP. Give you a clear explanation on heating and cooling degree days, something that's part of the calculations of cost avoidance and weather normalization. And then probably spend 15, 20 minutes at the end talking specifically about cost avoidance calculations. I have some graphs and charts I want to share with you to hopefully simplify it for you and help you understand it. So as I said, I want to start first of all with energy prices and what's projected over the next 5 years and beyond. I want to give you a second to digest this graphic and just allow your eyes to wander around the graphic a little bit. And I'm sure you'll see energy prices are going up, and they're going up a lot over the next 5 years and beyond. And if you carefully read this thing, there's a bunch of reasons as to why. You might start in the West and you see factors like climate change. Jump up to the Northwest, you see data centers and aging infrastructure in the Midwest. There's all sorts of reasons as to why energy prices are forecast to climb so dramatically in the years ahead. But the facts of the matter are that you need to realize that and react to that, because now is the time to take action. Control the things you can control and avoid costs as best you can. So with that in mind, we know prices are going up. Let's get into cost avoidance. And what I've got here is I've got a fictitious example that I like to share with you to highlight what many people experience as they learn about cost avoidance, or it even creates some skepticism from some that like cost avoidance isn't real. And hopefully over the next 3, 4 slides, I want to dispel that. I want you guys to see the facts of what's happening with the data and the things that are happening behind the scenes. So Organization X, again, fictional. Let's suppose over the last 3 years, they established a base year, and now they want to make some changes in their organization. Let's say this organization has tried to implement some energy conservation guidelines, which means they're trying to change their culture and change behavior. So they're encouraging people to do different things in order to save energy. And let's also say they've made some changes to the mechanical equipment. The facilities department has chosen to run equipment less in an effort to save. So they're working on it. They're trying to get better at their energy consumption and save money. Another thing they've done over the course of these last couple of years is they've completed a lighting retrofit. So you would expect, making those changes, you'd start to see it in the bills. The chart, though, in the middle highlights what happens for many organizations. Using 2022 as a base year, let's say their annual utility costs or their spend was 1.2 million. In 2023, let's say we look at that year as a performance year or a comparison year, and if you notice, their spend now is 1.25 million. And if you look at the change, there's been a financial impact, but it's been in the wrong direction. They've spent an additional $50,000 more. So now you think another year goes by, these changes eventually have to help us at some point, right? We're using less energy. We've made changes in our buildings, but now in 2024, another performance year, your utility spend has risen to 1.3 million. And now you're $100,000 greater than you were in the base year. So over the course of the 2 years you've assertively tried to change your behaviors and save energy, you're spending $150,000 more, which would be very disappointing for an organization. And I want to reiterate, this happens to many organizations. They try to make changes, but when you look at the raw data suggests that you're really not making any progress. I want to, over the course of this presentation, talk about very specifically raw data versus cost avoidance data. Sometimes people refer to cost avoidance data as savings and they mix it up with raw data. And I think it's important that you use your language and your words very carefully because different stories can be told with the data. And I think you have to be very careful with how you describe it so it doesn't compromise the integrity of the data or what people perceive as happening. So to summarize, Organization X has made some changes. They expected to see changes and nothing happened. So let's take a look at the changes over time. Let's track the changes during the first year. And this is unpacking it and looking at the impact of the things that have happened. So in 2023, some things happened. And one of them was severe weather caused the bills to increase. In this made up scenario, let's say the severe weather affecting Organization X affected the cost by $80,000. They also endured a rate increase that was substantial of another $70,000. So you've got these things that are adding to the costs, and at the same time, you've reduced energy use. So the reduced energy use was $60,000, and the lighting retrofit was $40,000. And if you look at the raw data going across and add it all up, you can see why the change over time was an increase, $50,000, because you had two factors beyond the control of the organization that caused things to rise. Let's take a look at the next year. Year number 2 in 2024. Severe weather, again, it was more severe than the base year, not as severe as year 2023, but because the weather was more severe than the base year, you would expect to have an added cost. Let me pause here for a second to think about this and what this means. If you have more severe weather, if it's hotter and colder at some point in time compared to a base year, think about the mechanical systems. They're going to have to run harder, work harder in order to produce comfortable temperatures in a building. And that has an impact, that has a cost. That doesn't come for free. We can't ignore that as part of our calculation. That's why it can have a value associated with it. And for this example, I've said it's had a negative value or it's hurt you 2 years in a row. It just as easily could help you some years, but it has to be considered. Again, it can't be ignored. Utility rates, we all see they're always going up. And people look at these numbers and they might question this. They might say, Tom, it went up $70,000 one year and $150,000 the next year. That's crazy. It would never go up that much. Keep in mind, utility rates are always and constantly rising. So one way to think about this is it rose $70,000 the first year. It rose $85,000 the second year, which is pretty comparable as the change took place. But you always have to compare it to your base year. So when you look at year 2024 in comparison to the base year, it's a total increase of $155,000. And again, having done this for years, these are reasonable numbers, reasonable percentage increases that people experience. I haven't falsely created these wild numbers that don't make any sense. These would be reasonable things that would happen in the real world. Continuing across for 2024, we can look at the reduced energy usage. Again, we've encouraged people to turn off computers, to manage their spaces more aggressively. Facilities department is continuing to manage the systems more aggressively, turning the heating and cooling off. And we've reduced $85,000 of costs as a result of those efforts. And once again, the lighting retrofit had an impact. But when you roll it all up for 2024, you notice you spent $100,000 more than you did in your base year. Again, if you just look at the bottom line, this could become disheartening, but now you have a better understanding of what's happening behind the scenes. That's what cost avoidance does. Cost avoidance allows you to determine each of the factors involved so you can have a better understanding. So in this chart here, what we've done is I've simply just rolled it up. So you can make statements like this. Severe weather or the weather changed over a couple years. It had an impact on the organization of 150,000. The utility rate increases had an impact of 225,000. Those costs are unavoidable. Those things are beyond the control of the organization and they're happening regardless. Cost avoidance is something you can control. In this case here, the cost avoidance would be the sum of the reduced energy use as well as the lighting retrofit. So that would total, I believe, to 225,000. Yet the raw change is still 150. So hopefully what you've seen over the course of this last 5 minutes in the explanation is cost avoidance needs to be part of the story. It can't be missing from the story because a lot of good happened in this organization, and disregarding it or neglecting it, I believe, prevents the organization from reaching its highest level of success. So to summarize this in another way is, had you not, or had organization X not made changes, they would have spent substantially more. They would have spent another $375,000 from the base year. And because of the avoided costs and avoided energy use, they've saved or reduced their costs by $225,000, which is an absolute huge win for the organization. So as I get deeper into this and more into the weeds and explain this, I wanted you to have a real world example of what happens. And raw data doesn't necessarily tell the same story as cost avoidance data. It can, under certain circumstances, if weather is less severe and utility rates aren't wildly changing, but it can tell two completely different stories. But I strongly feel cost avoidance has to be part of the bigger picture and has to be told as part of the story. Another thing cost avoidance data can do for you is it can allow you to do some quick, simple analyses of ROI. So with this example here, in the lighting retrofit for this fictitious situation, let's just say it costs $200,000. You were saving $40,000 per year. So doing the division, you'd see you get a payback in 5 years, which would be pretty typical for a lighting retrofit project. I know many people have gone through their lighting retrofit projects, but the same thing would apply for any type of project. If you take a look at your costs, compare it to how much you've saved, doing calculations of cost avoidance are very powerful because it allows you to verify these things. And what I really like is it allows you to hold vendors accountable. When they promise that you're going to have a return on investment after 5 years or 7 years, you can do the calculations and see if that's really happening or not, and make sure you're getting value from the contracts you sign. I know there are a lot of reputable companies out there that do great work in buildings, but it's always good to hold them accountable and make sure that you're getting what you paid for by doing the math behind the scenes and double checking to make sure that those ROIs are on target. So a statement I wanted to make to just maybe put a exclamation point on this is, without cost avoidance, no one sees the problems they've prevented, only the net impact on the bills. Again, cost avoidance is so important to understand all of the stuff that's going on, not just by looking at the raw data and thinking about what's the true impact on the bills. So why use cost avoidance? Well, I would say it propels organizations to achieve the highest level of energy efficiency. If organizations don't have that calculation, as the example that I just went through, they don't see that their efforts meant something, efforts stall. Financial people and facility people, generally speaking, don't communicate as well, and the ball gets dropped. And cost avoidance gives you something to rally around. It gives you a clear measure of impact, and you get to celebrate the success of it. Like I say, it builds momentum, gets everybody on the same page and excited to do more. So it justifies more energy projects. It helps you to fix broken systems because the CFO can see, hey, we spent a little bit of money on this, but oh, wow, we saw this great impact as a result. More money can be funneled back to the facilities department to get these things done. Another thing is it helps you identify the weather impact. There are these years where you save money. An organization spends less in utilities than they did the year before, and they have no understanding as to why. Very likely could be driven by the weather or other factors, but you just don't know. So cost avoidance allows you to determine that. And maybe the very last and most important thing is it clearly identifies savings opportunities as well, allows you to track stuff and find more savings out there. And so I think there's all of these reasons and probably many more. But it starts by, first of all, understanding what it is. And hopefully I've done that in the last 15 minutes where you have a better understanding what cost avoidance is. And then how do you calculate it? So let's get into the next topic of what's called M&V, or measurement and verification. What measurement and verification is, in summary, is it's a process or a technique of measuring energy savings. You might imagine this is complicated, right? There's a lot of moving parts here, a lot of different variables that could confuse people. And so we have to create this process to make sure that it's consistent and it's accurate. Back in the early 90s, there was this protocol that was developed that was called the IPMVP, or the International Performance Measurement and Verification Protocol. The idea was quite simply a bunch of smart people came together. They said, we've got to create a process that people can follow so this is consistent and accurate and people have trust and faith in the process. So it started back roughly 30 years ago and it evolved, and the process now is owned by EVO. So this organization, I've got a picture of the book here if you want to pursue this further, and also some links at the end of the presentation if you want to dig into this. But the main message not to be lost is people came together and said, we've got to find ways to consistently measure savings, hence M&V, measurement verification, so that people can trust it and we can use it to, it's used, this process, by banks and through ESCO projects. Rigorous M&V is done to quantify savings. And so loans can be won from banks and money can transfer hands. It has to be trustworthy enough that people believe in the process. That at its root is what M&V is all about. So more important elements of M&V is why do you do it? Like what's happening behind the scenes as the calculations are being done? And I've highlighted that with the bold print here. What you have to do in order to determine energy savings or cost avoidance is you have to compare what did you spend, so what did you actually spend, with how much you would have spent. So you're trying to measure something that doesn't exist because you don't know exactly how much money you would have spent unless you consider the weather, unless you consider variables such as rate changes and a whole bunch of other things that will come up over the next half hour. So M&V at its root allows you to make this comparison. What did you spend? And you can compare that, what would you have spent, and net out the difference. That is what's important about M&V. The IP MVP also has these categories of different ways to look at buildings and changes that are taking place. So this is getting a little bit into the weeds, and I'm going to try to do a good job of just summarizing this. And in some of the things I say in the next few minutes are maybe a little bit of an oversimplification, but my assumption is that some, maybe many of you on the call, haven't had any exposure to this yet at all. And I wanted to introduce it to you by simplifying it. It's really not that complicated when you summarize it. Yes, the execution of it can get more complicated because of the complexities in the real world. But for today's purpose, I want to keep it simple. And if any of you on the webinar want to dig into this more, please reach out to me. Please reach out to us, and we can make sure you get the information you need. So the IP MVP has these 4 different ways of looking at things that are going on in the buildings. And I want to start with option A. Option A is this idea. Sometimes when you make changes to buildings, they're real simple. The best example of that is a lighting retrofit. Lighting retrofits are simple because it's real easy to count how many lights you have in a building. And it's real easy to expect or measure how many lights you're going to be putting back into a building. So there's an easy before and after analysis that can be done. And the other thing that you're able to do using this technique is you can test the lights. So to, again, simplify, let's suppose you're doing a lighting retrofit for 1,000 lights And you agree if you were to sample 50 of those 1,000 lights, they'd give you a representative sample of the energy use for those lights. So those 50 lights could be removed from the ceiling. They could be put on a bench and tested. You could find out factually how much energy they are using. Same thing holds true for the new lights going into the building after the project is done. You could test them and find out factually what the load difference would be. So option A is looking at something that's very simple, a before and an after, testing it, measuring it, and netting out the difference. And that allows you to quantify the savings that would occur as a result of the lighting retrofit. Now, option B is similar but different. Now you're dealing with something that's more complex. Maybe you've got a system like a variable frequency drive, a variable frequency drive that's using a varying amount of energy as it performs. So maybe this variable frequency drive is on a pump, and the conditions in the building are going to vary from time to time. So you've got a piece of equipment that varies in a situation that's going to vary, difficult to estimate the savings that could occur as a result of that. So what you could do is you could put a sub-meter in near the pump or around the corner that measures the pump and other things involved. But the idea is for option B, you still want to have measurement. Like option A was taking the lights and putting it on a bench and measuring it. Option B, you're measuring it again, but you're using a meter to measure it for a part of a building. And so option B is trying to isolate the change and quantify it through the use of a meter. Now, I want to contrast that with option C, and now we're moving into a category of what's called whole facility change. What option C is conceptually similar to option B, but different in that you are making multiple changes. It's not just that retrofit or just that VFD that you did in option B. It's doing maybe dozens of different things around your facility for option C. And what you want to do is roll up all of those changes into the main meters for a building. So option C is very powerful because it allows you to capture all of the savings through your meters and to quantify that. But hopefully I've made it clear how it's distinctive and different than option B, where one is small and the other one's big. Option D, this fourth way of going about measuring savings, is actually what's called a calibrated simulation. These calibrated simulations involve software many times, and you're putting in all sorts of variables into the software in order to account for the load changes that are taking place. And the software then, you can use the outputs from that to calculate savings and the impact on an organization. So at a high level, those are the four different options. So what I want to talk about are the pros and cons associated with each of these four things. So for option A, just refreshing your memory, it's about the lighting retrofit. What's great about option A is the savings report correlate closely with the actual savings you see. It's relatively inexpensive to do. And so people are happy because it's cheap. And if you promise me $100,000 in savings, I get $100,000 in savings. But the con is that most people do many things simultaneously, and the projects are very complicated. So they involve the implementation of many ECMs. So although option A is great, it's utilized absolutely a ton in the real world, but it doesn't necessarily tell the whole story because there's more going on than just the one thing. Option B, these saving reports also closely correlate with the production changes, which is awesome. The actual savings are determined from direct metered usage. This makes people more comfortable, once again, if they can see a change from a meter. The people who look at M&V and are skeptical about the accuracy, they like true meter usage, and it helps them to be more comfortable because they can see it before and an after. But the cons with option B is the data doesn't necessarily reconcile with the other things that are happening in the building. Once again, most organizations are not doing isolated things. They're doing multiple things at once. And so it makes this complex. It makes it hard. It makes option B a strategy or an approach that isn't used as often as others. The other thing, and it's the last con down there, is this requires extensive metering, and metering isn't necessarily cheap. So if you're wanting to make changes in your building and it's going to require installing 5, 10, 15 new meters in order to measure all that change, you have to ask yourself the question, is it worth it? To get all of the data to tell the story about the savings that may or may not occur with that particular retrofit, you have to weigh the cost of installing the meters with the benefit And that's another principle of measurement and verification is you have to consider cost versus benefit and make sure that's part of what's discussed by the parties involved. I want to just take a quick tangent here and just make sure that I share an important concept of M&B. The idea is every project that's done is supposed to have an M&V plan. So the organization that's actually doing the changes and the organization that's paying for it, they should sit down around a table and come up with an M&V plan. And what the IP MVP says, if everybody involved agrees with the plan, then it's legitimate. So one plan might be different than the next and the next and the next. But what's critically important is all the parties should be involved with the discussion of what the plan's going to look like and agree to its execution. That in and of itself, the IP MVP suggests legitimizes the plan. So no, because this world is so difficult and all the complexities, it involves communication and conversation, and people have to agree with what's happening. That's what legitimizes it. So getting back to option C and just talking about the pros and cons of option C. So option C, as I stated earlier, is very popular because it's easy to do. What's neat about this is it allows you to roll up all of the impact in your organization. So it evaluates the performance of the entire facility. It factors in all of the different things that are happening. So you might choose to do a lighting retrofit. You might choose to replace a variable frequency drive. You might choose to operate your systems differently. Similar to this organization X example that I started with, this might be the strategy that they would choose to use. Even though you could figure out each of the individual pieces of savings, why not roll it up into one total? And so that's a pro, but it's also a con because some people want to know the details of each of those different things. So there's no easy way to separate the impact of the individual events. And so it's easy, it's relatively inexpensive to do, but it doesn't give the detail that some people would really like to see. And the real power of this is you need the utility data. So getting access to the utility makes this thing really, really easy to do and to crank out results. Finally, the last option, option D, is this idea of calibrated simulation. I mentioned earlier that you're using software, you're doing calculations as software is spitting out information for you. This is appropriate and typically used in the situation where there's new construction or there's no baseline data. So an example might be as you want to build a new building. There's physically no building that exists. You could do a calibrated simulation and project what the loads are going to be. That's certainly legitimate to do, but there's no baseline data. Or it could be an existing building and you're adding or subtracting from it. And so the data isn't complete. Calibrated simulation is a technique where you fill in the data with reasonable values, use a computer simulation to calculate loads, and then use those calculations for additional calculations to talk about savings and change. The great part of this, and it's also a con, is this gives transparency and credibility in these complex situations. So that is fantastic. The problem is that some people can't understand it. And I don't say that with criticism, but some people have engineering minds and the engineering background to appreciate the nuance of all the changes that are happening in a building. So you're changing insulation, you're putting a new roof on, you're changing windows. There's so many different factors, the width of the walls, the R values of walls and insulation, and just a zillion different things that are going on. Some people have the knowledge and the training to appreciate that. And when they see simulations involving that, they can accept it as legitimate. For others, because they lack the training and the understanding of those things, they view it as a black box or uncertainty, and they struggle to accept its legitimacy. So calibrated simulations certainly occur out in the real world, but people tend to shy away from them because many times involved in these conversations are the engineering personalities, the financial personalities, and other people who don't have as much training. And because, as I described a few minutes ago, everybody has to accept these plans as legitimate, you need to make sure it's at a level that everybody can understand and appreciate. That's what makes an M&V plan good for people. And the last thing to highlight here is these things are usually very time intensive, where it just takes a lot of time to do these calibrations. And so that would be another reason why people might err away from or lean away from using option D. Sarah, did you have a question? I see it popped in there. Was there any questions come up or something?
Hey Tom, we've had a few comments come up. John, I really like yours. He said, if I don't take my kids out shopping, can I count that as cost avoidance? I absolutely,
Amen. Yes.
I actually think that you should enter them in EnergyCAP as custom commodities and track it because you could absolutely do that. And then we had another, I think this is really interesting. Keith brought up the point, they have been using cost avoidance for many years at UCF in a variety of ways, primarily through us, through EnergyCAP. And they tend to create regression analysis models with interval data. Also, depending on the situation, which I think is a really key and interesting point. And certainly talking about cost avoidance and talking about uh, interval data is talking about peanut butter and jelly for sure. So I think you talk about that a little bit more, but definitely of interest to the audience.
Yeah, yeah. So what I would say is all of this analysis is improved with better data. So if you're in a position where all you really have is utility data, you don't have real-time data, you're going to get good results. But the more data you can feed in and calculate, the more legitimate the results are and the more acceptable they are. Because the people who live in this world can see it and understand it. But again, part of communicating this data is sharing it with people who have less experience. And so the more you can bring in, the more graphs and charts and the flow of thinking people can see, the more comfortable they're going to be. Because my concern is that these projects don't get done because people don't think the savings is real. And I think that's a shame because what's limiting the process is there isn't a clear understanding of the savings. And so therefore it stalls. And so that's what I'm trying to do, hopefully in this webinar. And what I passionately believe is the more people understand it and can appreciate it, the more likelihood they're going to accept it and more things are going to get done. Let me jump into the next topic here. Thanks, Sarah. And please, again, jump in if there's more questions. But I want to start to move in a little bit more. I've explained so far kind of my beliefs of cost avoidance and this IPMVP, just the measurement verification. Let's start to get into more of the variables. And there's a term in the industry that's called heating degree days that is a little confusing for some. So I want to help explain this. Let me start by on the left-hand side, I have a number there as a base temperature, 55 degrees. That is a number that's used in calculating heating degree days, and I want to explain as to why. What the concept of heating and cooling degree days is measuring how far the temperature is away from a really, really good day. And so let's talk about that 55-degree day. If you have a 55-degree day outside, usually that means, if that's the average temperature for the day, it usually means the high temperature for the day is maybe 10 or 15 degrees above that. So it's 65 or 70 for a high, and it's usually 10 or 15 degrees below that. So the temperature might sink to 40 or 45 degrees. Most of us in most parts of the country, and certainly not everywhere, so this is probably an overgeneralization, most people experience roughly a 20 to 30 degree swing in temperatures from sun up to sundown and through the night. But what many people believe is that the 55-degree day is the perfect day, or at least it's the perfect day in terms of energy use. So you have a 55-degree day. Again, the high temperature gets up to 65 or 70. Most of us don't turn on our air conditioning systems when it's 65 degrees outside or 70 degrees. Usually we wait till it's 72, 78 degrees. We turn on the air conditioning. And likewise, the same thing with cooling. I live in the Midwest, and to me, a 55-degree day usually is in the spring and in the fall, and those are the perfect days. The screens are on the windows, the house is just comfortable all day long. So conceptually, the base temperature using 55 degrees, the thought is it's the day that represents the minimal energy use. So now average temperature being 40 degrees. So let's take another day when the average temperature is 40 degrees. So now, again, if it's 40 degrees, probably means the high is 50 and the low is 30, or maybe the low is 25. And that now means you're very likely turning the heat on in order to be comfortable. So when you calculate heating degree days, what you're doing is you're taking the difference. You're subtracting 55, that perfect day, minus the 40, and you come up with 15. So 15 represents the number of heating degree days. So every day you could do a calculation of heating degree days. So you might have 15 one day and 12 the next and 27 the next. How heating degree days are used in the software and in the industry is they're always rolled up for comparison. So if you take your heating degree days for a month and come up with a total in a cold month, again, I live in the Midwest, so January might have 600, 700 total heating degree days. The purpose is to give you a relative comparison, because if this January in Michigan has 700 heating degree days, what matters is how many heating degrees days did you have last January? Was it also 700? Was it 600? Was it 800? So the purpose of calculating these heating degree days is to do comparison month by month and year by year, so you can factor in how much the weather is affecting the energy use. So if you understood that, hopefully cooling degree days is a very similar and easy to understand. Concept is, again, you're using the perfect day, and the subtraction simply just changes. And now we're talking about cooling. So for this made up example, the average temperature is a 65-degree day. Again, think about that. If it's 65 degrees, probably means the high temperature was 80 degrees that day. The low temperature might be down to 50. But usually, if it gets up to 80 degrees, many times people start turning on the air conditioning. So if you want to figure out what your cooling degree days are, you simply subtract the 65 minus the 55, and it becomes 10. Similar to what I said a minute ago, these can be rolled up to total. You have 10 one day, 12 the next, 15 the next, day by day by day. You can figure it out. I should say this too, just hopefully that's clear. If you have a 55-degree day, well, you have no heating or cooling degree days. That day would account for 0. So that possibility definitely exists. But the reality of it, again, you can total them up through the cooling season. How does this July look with last July, compare? And the numbers, once again, in the extreme months, they could be 600, 700, 800 cooling degree days. And so now we have data. Now we have a way of looking at how the temperature is affecting. So how are they used? That's what I want to talk about next. So this next slide is on weather normalization. So the concept here, and I need to, hopefully you can see my cursor as I move my mouse. Those heating and cooling degree days are plotted on the axis, along the x-axis, and energy use is plotted along the y-axis. So weather normalization is this idea of looking at how hot or cold it is and how much energy you are using. So along the x-axis here, again, you see degree days. Because this is cooling, what you're really looking at is the temperature outside. So that last example I gave a minute ago, what we calculated is we had 10 cooling degree days. So on this graph, the 10 would be way out here. This is obviously more simple, but the idea being that you're looking at how hot it was outside versus how much energy use. And if you remember your math from school, what you have here is you have a positively sloped line. So this positively sloped line means that as it gets hotter and hotter outside, you're using more and more energy. That is the relationship we're trying to find. So weather normalization is trying to identify when it gets hotter or colder, your energy usage is going up. I wanted to give you a counter example down here where you can see same type of thing. Now it's getting, as you move to the right in the graph, it would be getting colder and colder because we're looking at heating, but this relationship is now going downhill, or it's what we call a negatively sloped line. These are thrown out by the software. In the next 10 minutes, as I move towards the end of the webinar, what I want to do is talk a lot about EnergyCAP. So you can see the features as I've described. And what you're looking at here is what specifically came out of EnergyCAP as a screenshot. So as I describe these things, I want to start to reference EnergyCAP and what's happening. So EnergyCAP in this situation here, when you have a positively sloped line, is going to look at the statistics and make a decision whether there's a close enough relationship between the temperature outside and the energy use. EnergyCAP will then, in a situation like this, because you have a negatively sloped line, it's going to disregard this because it's going to say, you know what, energy use was going down as the temperature became more extreme. So these and the statistics zero out and nothing gets done. So EnergyCAP is making those determinations for you as it calculates the weather impact on cost avoidance. Let me talk specifically about cost avoidance and blend in what I've described in the last few minutes on heating and cooling degree days with this model that I have here. I've got this chart here, and I want to talk about the concept of cost avoidance, and it's predicated on a few real simple ideas. You need to establish a fair baseline. You need to account for weather, can't ignore weather, and you have to consider everything else that's going on. And so what I've got here along the bottom are 3 different bars. And I want you to understand here on the side here is the energy use that's taking place. So after establishing a fair baseline, usually when you talk about cost avoidance, you think about it in a month's time. So the dark blue part of this bar would be how much energy was consumed or used regardless of the weather. And the light blue part of the bar is how much energy was used or consumed because of the weather. So EnergyCAP is going to take the baseline conditions and disaggregate the data and find out how much energy you're using no matter what, and how much energy is due to the weather. Sarah, I see it popped in. Did you have another question?
Yep. So Melanie, hi Melanie, one of our most favorites, made the comment, is it correct to assume that because you are using heating degree days and cooling degree days, that humidity is not ever taken into account or does not have to be taken into account in these calculations?
Excellent question. That gets into it's an interesting question because it's the layer of complexity. EnergyCAP, in the calculations done as a weather adjustment, is only considering the temperature. Does humidity affect the amount of energy that's utilized in the building? It does. But what most statistics show is that when you start to factor in, to take the effort to include humidity in all of the calculations, it does a couple things. Over the course of days, in weeks and months of time, humidity doesn't seem to have a dramatic effect because what helps one day hurts the next day, and it kind of plays itself out over time. And the other thing, as part of the IPMVP, the reason why temperature is the primary thing that's used is because it keeps it simple. I mentioned earlier in the discussion is that part of calculating cost avoidance, it has to be comfortable for people. If it becomes a black box and people begin to question it because it's so complicated and there are so many variables involved, people put up their hands and say, nope, I don't want to hear anymore because I'm confused. I don't want it. So hopefully that makes sense. Temperature is used because it is the driving factor that's going to cause buildings to use more energy. And so it's the primary factor. It's part of the calculations. If you look at the nuance of this, for sure, humidity has an effect, but relative to temperature, that effect is small. And over time, humidity, it kind of plays itself out. Again, the positives and negatives, they offset one another over time.
Perfect. And Melanie said that that's exactly what she thought, just confirming.
Yeah.
Thanks,
Awesome.
Melanie. Good question.
Yeah, excellent question. And again, a very common question as people start to get into cost avoidance. So picking up my explanation, so the first thing you got to do is establish a baseline. You got to take the baseline consumption apart, disaggregate it into what's base load and what's weather load. And then what you have to do is you have to take a look at what's happening in today's conditions, because you can't compare something apples to apples if things have changed. So you have to adjust to make it apples to apples. So that's what this middle bar is attempting to show. And I want to show you why each of the colors of the bar have changed. And an example of that is in this baseline condition, the dark blue bar, part of the bar, might represent a 28-day billing cycle. So that's what's represented going from bottom to top. This dark blue part on this bar might represent a 32-day billing cycle. So in order for you to compare a 32-day billing cycle with a 28-day cycle, you have to consider what's to be expected. So that is what's being shown here in the dark blue part. What hopefully is obvious is because this weather part of the bar is much bigger here than it is over here, this would be an adjustment for weather that is less severe. So it's more mild. So you have taken what you learned in the base year, you have translated into what's going on in today's conditions, and now you have the ability to compare it to what actually happened. So the third bar over here, again, you're breaking down the data, you're disaggregating it into a base load, or what you're going to use regardless of the weather. And then there's the weather piece. And so this total bar in comparison to the adjusted bar allows you to decide, is there savings or isn't there savings? Now, some people think cost avoidance always has to be positive, like you always have to have cost avoidance. That's not true. It's very possible to get negative cost avoidance. This example that I've put together to describe this shows a positive savings, but it doesn't have to be. Cost avoidance is intended to be a fair comparison, whether it be positive or negative. And so I think where it starts is having this clear understanding of what's going on and then applying it. And if it turns out positive, fantastic. And if it's negative, then so be it. One of the things that's on the slide here I want to make sure you see is this savings, though, can be used, similar to what I did earlier in the presentation, to calculate ROI. And it's such a powerful piece for people to understand. So just know once that's calculated, you can determine ROI. Here's another picture, and it's similar to what I showed you a second ago, but it's showing it over time. So giving you a chance to digest this picture, what you've got over here on the left-hand side is energy consumption. And on the bottom, it's time. So time is going by. So we've got a measured baseline, or this blue line going across is showing you your profile of energy usage. And now we intersect this installation period, or an ECM. An event took place to change something, for the better or worse. We just know something has changed. The blue line continues moving forward. And if you notice, it's substantially less than what it was previously, but something happened here because now we're using less energy. The only way for us to determine what the benefit of this event was, this ECM was to generate an adjusted baseline. And so this green line represents what would have happened, what would be a fair comparison in this particular circumstance. And so then when you calculate the area, the green shaded area, this represents your cost avoidance. That is what EnergyCAP is doing. EnergyCAP is taking all of the utility data. It's allowing you to establish a base period. It's doing the calculations, generating this green line, and then determining, do you have area there that's positive or negative? So that's cost avoidance seen from a couple of different ways with the different graphics. I want to race through a couple different slides here just to show you a little bit more about EnergyCAP. And we've got about 15 minutes left. I don't want to try to leave 10 minutes or so at the end to answer any questions you might have. So these are screenshots from EnergyCAP. You can see labeled at the top, there's electricity and natural gas. And I put this in here to just make sure you know that you are in control as a user of the software. You can look at all of your electricity meters, all your natural gas meters, look at the slopes of the lines. Are they positive? Are they negative? The software will automatically turn these things on and off when it finds an adjustment. But you as the user have the ability to scrutinize these and take a look at these. And I also want to highlight at the bottom here, all of this is IP-MVP compliant. So as EnergyCAP is doing those calculations and running the analysis, it's meeting all of the criteria for the IP-MVP. This is how you would establish a baseline within EnergyCAP. Simply clicking and toggling to identify a start and a stop. You are not limited to have a baseline of 12 months. I would encourage you to have no less than 12 months. If you're doing comparisons over time, you really want to use a year of data, but the software gives you the ability to set an 18-month baseline. If you have, suppose you have data or something change in your organization, you just want to kind of roll it up and capture and average it out, you could use baselines that would be different than 12 months. The software also calculates the value of cost avoidance using average unit cost by default, but there are different ways to do that. And I also want to take a second to drive home this point, is that the way EnergyCAP works to calculate cost avoidance, it takes a look at energy change over the course of time. So it looks at creating these adjusted baselines and doing comparisons. But an important part of the IP-MVP is how you value the energy change. And what people usually choose to do to value the energy change is they take a look at average unit cost and they take a look at today's rate. For many people, it wouldn't make sense to value the energy change by looking at the value of energy back in 2015, and it wouldn't make sense to use the value of the energy in 2030. It's what is the value of the energy at today's point in time. That's what the software is doing by default. Another part of what EnergyCAP can do is it allows you to account for other things like schedule changes or occupancy changes or extreme weather. These are factors. They are things that you may or may not want to include as part of your cost avoidance calculation. EnergyCAP puts you in charge as the user of the software to say, hey, I want to factor that in, or hey, I don't want to factor that in. And so this, again, I'm just highlighting and showing you that it exists, but there's some complexities here and some things that would need to be taught. But these are important parts of the power of the software. And once again, it's all IP-MVP compliant, but these are the common things: schedule changes, occupancy changes, extreme weather. All of those things can be factored in your cost avoidance calculations. Primary part of this graphic that I put on the screen that I want you to see, and I think this is hugely important, is cost avoidance is calculated monthly. So you can look at your monthly cost avoidance over the course of time because it tells a story. And I simply want to unpack this a little bit for you so you can see. So for this example, someone set up cost avoidance or doing calculations, and this is showing, hey, back in March 19, we saved. The green bar represents savings. So month by month, they're doing okay. Started to regress here for some reason. And all of a sudden, they start to see whoppers of savings. And if you think back to what this was, this would represent the pandemic. So of course, the building was operated differently. People weren't in the building. And you can calculate cost avoidance during that period of time. Or you might say, you know what, I don't perceive that to be legitimate cost avoidance. Well, again, the software gives you the chance to include it or exclude it, but that's what's happening here. That's why these bars are growing so great. But then over time, you settle into more of a pattern. And I think this is the powerful part. This is the part that people can see month by month what's happening. And if the bars start to turn orange, then it means something has gone backwards in your organization. And if the bars are green and you're tracking it over time, success is happening. Changes that are taking place or retrofits, things that are happening within your organization are impacting in a positive way. And I think this is, to some extent, the big enchilada. This is what people need to do because this is how you understand your buildings and you see how they're progressing month after month. This is just another screen that shows you behind the scenes what's happening. I want you to see with EnergyCAP, the calculations are shown here. There's baseline usage, and this is a BATCC, or baseline adjusted to current conditions, or what I'm calling the adjusted baseline. And it breaks everything out: energy use, non-weather energy use, costs. And so a little glimpse behind the curtain, if you're not currently an EnergyCAP user, or if you are, but you haven't made use of EnergyCAP's cost avoidance module, this is showing you all the numbers. And it's that transparency piece that I'm saying is just so important. People need to see the numbers in order to trust the numbers. Finally, the last thing is other savings. What you do many times as an energy manager, somebody who's working in the field, is you try to save money in many different ways. What EnergyCAP gives you the ability to do is to capture savings, things that occur that EnergyCAP would not be able to capture through utility rate reductions or through utility energy reductions. So this is an example here on the screen over to the right where you maybe have negotiated a reduced utility rate with your vendor and you simply want to include it in the software to make sure you're getting credit for it. That's what's being shown here. Another thing on the screen here, you might see rebates. So something you might be doing as an energy manager in the field is working with your vendors and winning all these rebates. EnergyCAP gives you a chance to capture that and roll it into the software. So when you run reports, it's all in one spot. It's all organized. And as you make a case for why you're having so much success in your organization, saving energy and money, it can be found in one spot and it's easy for people to see. So as I wind things down, just wanted to make sure you realize there are some resources here. I mentioned when I talked about the IP MVP that EVO is the organization that manages this. So if you're looking to read more about it, go to EVO. Also want you to know that all of this stuff, AEE, or the Association for Energy Engineers, has a certification called a CMVP. I am actually a CMVP, or a Certified Measurement and Verification Professional. What that means is I have training in all of this. And so AEE supports the idea of people learning this because it helps us all to better understand it and share each of these changes that are taking place in our building and win more support for energy efficiency across the board. Wanted you to know too, tomorrow we have a Eco Champions workshop tomorrow. Whoops, I didn't put the time in here. I'm going from memory. I think it might be 1 o'clock tomorrow afternoon, but it's what we call a water cooler talk. If you aren't familiar with EnergyCAP, we try to get people to together once every couple of weeks and just talk about things. Tomorrow's conversation is on the green revolving funds and just people using them and how they're taking advantage of those. And we've also got a workshop on the following day talking about Carbon Hub, just some carbon emission accounting. And with that, Sarah, I think I'm done with the presentation. So if I can invite you back in and see if there's any questions or comments from people out there in the ether.
Yeah, so there were some questions about joining the water cooler chat. Jamie, and Daniela has put the invitation in there, but that's directly in our Eco Champions community, which is very easy to join and has lots of other things besides just water cooler chats. There's ongoing open chats by topic. We have special sessions of learning, open office hours to ask your own questions. So lots of good things to do there besides just the water cooler, although water cooler is also a really good resource and a great thing to go to. We do have a first question around if your organization is already beginning to implement submetering, so you're putting your submetering in place, would that make option B more attractive than option A for IPMVP?
Well, I don't know if I can generalize and say that I think so. Like, I think I'd say probably, but there are so many variables involved if you're putting the sub meters in. The great thing is if you're using EnergyCAP or you're tracking your utility data, if you have a historical marker, meaning that you could put, if you have data hypothetically that goes back to 2020 and you have an understanding of when these events took place, when meters went in or you're making changes and additional things are happening, it tells the timeline of everything. So EnergyCAP would allow you to turn on cost avoidance or to put markers in and to record events and things. So I don't know if I've necessarily answered your question other than I'm excited for you that you're putting sub meters in because it's a really good thing. It could never hurt you. It can only help you. But I get excited also about the ability to start to measure stuff. So having those sub meters can help you to measure and having that history is also really powerful.
Yeah. And we also had a question about outside of by the building or the meter or the individual project, seeing savings by portfolio. So your overall M&V, your overall savings, which I know EnergyCAP can do, but please tell us about that.
Yeah, so what I would say is, I had mentioned early on, just as I introduced myself, that I, worked in the industry for 20 years, and I've helped hundreds of clients using EnergyCAP calculate cost avoidance. And the power, I think, is being able to have measurement at different levels, where you can measure cost avoidance at the meter level, the site level, or even organizational level, because I think all of it has interpretations that can help an organization. So again, I think the power is the data. It's rooted in the data, having the data to start with. But I want to encourage you to consider who your audience is and what they need to see or hear in order to change them. Because I'm guessing many people on the call, our primary goal in our job is to try to change behavior or move people to a new place. So use the data as the tool in order to do that. And if it isn't completely obvious, I say it over and over again, just how excited I am for EnergyCAP, because I think it just allows you to dissect the data in so many different ways. It just can really help you get to where you need to be.
John Pierce, also one of our favorites, made a good comment. Part of the challenge is where submeters are being installed, which is a really good point.
Yep,
So are they at the
absolutely.
building level? Are they in front of every piece of equipment? That matters a lot. At the building level would still be option C. So definitely a good thing
Yeah.
to remember.
Yeah. And what I would say is part of for the person who asked the initial question is what you really need to do is get out in the field and understand all of the meters you have and very clearly understand what they serve. Because many times my experience tells me is people assume because a meter is in one wing of a building, as a for instance, they assume it measures everything within the wing, and that might be a faulty assumption. And so make sure you're doing your homework in order to do a good analysis. You have to make sure that you truly understand the data that's flowing into your system.
Yep. And I know we're just about running out of time here. Jamie asked about if you will get access to the slides in the webinar recording, to which the answer is yes, absolutely. Those things will both be sent to you. The recording will also live on the website, so you can send anyone who you'd like to see the recording. Either you will receive that or you're welcome to send them to the website as well, where it will live for the indefinite future. So I know there's some additional chatter going on, but we're coming up right to the end here. So Mike, thanks for chiming in as always with some good information and good commentary. And I think unless there are any other short last minute questions, I think we've covered what we can cover in the time that we have. And of course, remember water cooler is coming up. So if there were questions that you were not able to get answered here, that's a great place to do that.
Awesome. And Sarah, I would just chime in. I just, it's my person. I like to open myself up for additional questions. If anybody wants to email, please email I don't want to promise more than what I can deliver, but I do want to open myself up to help however I can. So thank you for joining the webinar today. And I will sign off, sir. I don't know if you want to finish with some, but I will sign off and say thank you and have a great day.
Yep, that's it. And again, yep, everyone, please join Eco Champs. We're going to continue the discussion there. Thanks so much for joining us.